Hello, hello. This is Miss Pitts back. We are working on standard maths.3.g.1.1. That's classifying quadrilaterals. So classifying means that you can just kind of organize them and put them into groups. Quadrilaterals, that's a specific type of shape. So it's not about every single shape, all the polygons, which just mean closed shapes with straight lines. And it's not just about like circle versus a triangle. That's stuff that you would have already learned. So they're kind of banking on the fact that you're going to be ready to get into these four-sided closed shapes made only with straight lines. Okay. So I made a quadrilateral family tree to help you guys. And of course you guys are going to see this on Teams as well, the document. And I'm hoping that it can help us with some of our quadrilateral questions. So that brings us to our first point, a quadrilateral. A quadrilateral has four closed sides and four corners. These have to be straight. So if you notice here, each of these lines are nice and straight, as best as I could do, really. Okay, and there's four of them that are all connected. That's basically it for a quadrilateral. You're going to see that all of these that follow are different types of quadrilaterals. We'll start with our side for the trapezoid. So a trapezoid has to have these conditions, four closed sides and four corners, but then it also has something else. Only one pair of parallel sides. Parallel means that they're no touchy. No touchy. They're never gonna cross. It's very sad, but it's also very convenient because it's easy to draw things that aren't gonna cross like that. So this line, no matter how far it goes, it could go forever. It can go forever. And then this opposite side can go forever. These lines are never going to touch each other. But then we get to these right here. These lines, if they kept going forever, are going to touch. That means that they're not parallel. They will intersect at some point. So they give a little smooch. If your lines are smooching, it ain't right. Think of it like an adult at a party. Parallel. No touchy. Keep parallel. No smooching at this party. Here's another example of a shape that's also a trapezoid. It's a trapezoid because its opposite sides will never touch because they go right along with each other. They're always the same distance apart no matter what. But then this part here, these are going to touch. So if they're going to touch eventually, then they're not what we're looking for parallel sides. So only one pair of parallel sides makes a trapezoid. Trapezoids kind of stick together. Like once it's a trapezoid, there's not a whole lot more classification except for if it would be like isosceles or something, but you don't have to know about those. That's going to be something you find out later, so we're going to skip it for now. Make sure you understand these basic concepts and then you can go back to it in, I don't know, 4th, 5th grade. I don't know. I should probably know that. Guess I got some studying to do. So then on the other side, parallelogram. See the parallel in parallelogram? Excellent. I'm glad you took a moment to look at that because it's important. Your opposite sides are parallel. So these sides here are going to be parallel. They're never ever going to touch. See that? No touchy. They're opposite, left and right. Then up, this side is parallel to this one. They are never ever going to touch. Parallel means that they won't touch. No touchy. Now, for a parallelogram, there's different ways. See how the family tree goes out and then it comes back in, okay? it can go to a rectangle. A rectangle is a special type of parallelogram. A parallelogram is a special type of quadrilateral. So if it goes in this family, that has to have everything that comes before it. So a rectangle has 4 closed sides. That means they all connect. Check. It has 4 corners. 1, 2, 3, 4. Check. It has opposite sides that are parallel. Parallel with this side. That's not perfect, but you know, I drew it. And parallel, around opposite, left, right, and then up and down. Also parallel, so they're never ever gonna touch. No touchy touchy. It also has something a little special called square corners. Square corners, or if you are an elderly such as myself, this would be called a right angle. Your parents might know the right angles. It means that this is going to be exactly like a square. So to be exactly like a square, I need something. I didn't prepare properly. So to be like a square, you're going to be able to fit things within it, fit a piece of paper within it. Let me take this. Ready. So to be exactly like a square, you've got to be able to fit that 90 degrees, its square corner right in there, okay? That has to be all 4 corners have that. It can't just be some of them, because like look over, if we go back to our trapezoid, look at that. That can have a square corner too, but it doesn't have 4 square corners. Now, to be a square, it has to be a quadrilateral, 4 closed sides, 4 corners. It has to also be a parallelogram. Opposite sides are both parallel, 2 pairs of parallels. It has to be a rectangle, that it has 4 sides and 4 corners. And it has to be a rhombus. So a quadrilateral, 4 closed sides and 4 corners. The parallelogram, opposite sides are no touchy-touchy, parallel. And the rhombus, all sides are equal in length. So our sides are all the exact same length. This is not a rectangle because it doesn't have those square corners. If I try to fit this in there, I can't. There's still more left. So it is not square corners here. That's the difference between the rectangle and rhombus. That's why they go apart, but then they come back together for a square, because a square has all 4 sides the same length, or equal meaning the same, but a square also has the 4 square corners. So to be a square, it has to have all of those things. I'm sorry, I smudged this. I'm using some new markers. I'm still getting the hang of them. They are smudgy. If I don't like it, I think I'll probably change it. Anyway, it's got it all. It has all of these things going down for this side, the parallelogram side of the quadrilateral family tree. So the square, super special. It's a special type of quadrilateral. It is a special type of parallelogram. It is a special type of rhombus, and it is a special type of rectangle. So a square has all of these classifications. So they ask you, is a square a parallelogram? You're going to say, of course. But then if they say, is a parallelogram always a square? You're going to say, nope, because sometimes it might be different, right? This is a parallelogram, and it is not at all like a square. It doesn't have the 4 square corners, and all sides are not the equal length. So when they're asking you these questions to actually classify the quadrilaterals, you need to know the relationship between them so you can answer those questions. All right, guys, if you got questions for me, please contact me. I am lonely in my office hours. I want to chat with you. Also, you're going to see this document up on Teams to help remind you of what we've learned today. Remember, contact me. And I hope that you have an absolutely fabulous day. I'll see you next time.